We've got this little mini unit here called Parametric Equations.
It's a pretty important mini unit though, so definitely pay attention.
Yes, so the deal with parametric equations is it's a different way of graphing, kind of like polar equations was, except we're still technically in the rectangular coordinate system, so it's still like familiar. Oh, sorry, thanks. It still should be familiar graphing, but what we do is we add this thing called a parameter, t, and we make it to where that t helps us if we, for example, wanted to talk about like the time that a particular thing is moving through the XY plane.
You know, for example, an airplane taking off.
An airplane taking off, yes.
Is a good example of a parametric equation because you've got the time of the flight, the speed of the flight, and the altitude of the flight. And we can relate all of those together with two equations like this.
Absolutely. And the reason why it's so important is because you may have like an airplane or a car or whatever you want. It may be going like along this line, and then you could have a different one that is maybe going along this line, and you may be like, oh no, they intersect, that's bad. But it's so important about what time each of them gets to that point.
Right, like if Mrs. Stevenson's driving to school and she blazes through that intersection and I come along 5 minutes later,
then
it
our
might
paths
look like
crossed,
we had a crash,
we didn't crash.
Here we are teaching.
Yeah, so we'll deal with that a little later, but that's just kind of the idea behind why it's important. And it's actually really easy to work these out if if you'll pay attention and follow along with us.
Right, it's not hard. And remember that this is giving you an x coordinate and a y coordinate. And I'm sure with your brilliance you can figure out which one's which here.
Yeah, and each time when we graph, we have a set of equations now instead of just one. So an x equation and a y equation, they both have t's in them. So if we want to plot a system that from -2 to 2 for t, what we do is we plug in -2 into each equation and get an x and a y value, and then that x and y gives us our point.
Right.
So let's
because you have to have an x coordinate and a y coordinate to get a point.
Right.
Yeah.
So for x, when we plug in -2, that's -2 squared, which is 4. And then -2, if I plug it into y, it's a little bit more complicated.
Well, but not overly so.
No, just a little bit more math. So that's 4 plus 6.
That's 10.
That's 10. Okay, and so then I have no idea what our numbers are going to look like, so I'm going to hold off on graphing.
Yeah, don't graph it yet.
Yeah,
let's get some numbers,
So let's plug in -1, and you don't even necessarily have to write it out if you can do it in your head. -1 squared is
1.
Yeah, and then -1 squared, which is 1.
That's 1.
Minus 3 times a -1.
That's plus 3.
So that's 1 plus 3 is 4.
That's 4, yeah. And if you can't do that bottom guy in your head, no problem. Write it out by all means.
Absolutely.
That's totally okay.
Yeah. Totally okay. So plug in 0. Now this one you should be able to do without too much trouble.
I don't know if I can do this one in my head.
It's 0 squared is 0. 0 squared minus 3 times 0 is also 0.
How do you know that?
It's like it's been ingrained in me. Like, bam, 0.
You're brilliant.
Thanks. 1 squared is 1. 1 squared minus 3 times 1. So that's 1 minus 3.
That's 2.
Negative 2.
Negative 2.
And then how about plugging in 2?
Hold on. Now let's talk about this real quick. Notice that -1 and 1 were different, even though things are being squared here. So it's really important that you check every instance of t and not just assume that just because you have a 1 or -1 that you're going to get the exact same number.
Right.
Which often happens with
parabolas.
With
like
parabolas.
If you look at this,
that's not an uncommon thing.
It may be a parabola. It may not.
Yeah, there's no telling.
We'll have to find out together. 2 squared is 4. And then 4 minus 3 times 2, which is 4 minus 6, that's -2. Is that right? Do you actually do that along with me? Why don't you just check it while I make my x and y axis?
2's 4 minus 6. Yep, -2, yeah.
All right, so there's my y-axis, and I'm going to put my x-axis about right here.
Yeah, it's a good call right there.
You
line
don't
it up
have
perfect.
to be exactly where mine are on yours. Just I know that we need to go up to. It's a little crooked. I think we'll.
The OCD kids are going to have a hard time with that.
I know I need to go up to y equals 10, and hopefully I did that actually. 1, 2, 3, 4, 5.
Start again. I lost track.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, you
so
are good.
I did make it
okay,
that far.
Excellent.
Okay, so when I plot this first point, 4, 10, I need to go right 4
And then up to
and
10.
then up to 10, which is this
all I
one,
want.
right?
Yeah. Sorry, a big yawn there. We had a big game last night, Mrs. Stevenson.
Okay, and then like one thing you can do here, because if we just plot that point, we have no reference for t. You can just put out to the side here, t equals -2.
Yeah, t equals negative. There you go.
Okay, then we're gonna do 1, 4.
So 1, 4. So that should be a pretty easy one to go. 1, 4. There's t equals. That's what happens when t is equal to -1.
0, 0, 0, 0, 0. Well, maybe that was a few too many zeros, actually.
But there's
you
2
get the
zeros
point.
for sure.
Yeah,
For
that's
sure.
t equals 0. And how
This
about
is looking kind of
1, -2? Kind of weird.
Kind of an excellently looking oblong-y shape.
Is that a real shape?
I don't know.
T
We're making it up.
equals 1?
Yep. And then 4, -2. How did it flatten out? I don't get it. Did you make this up?
No. I think you did, actually.
What? That's weird.
So,
Wow.
we could connect these if we wanted to, but is that
I mean,
something
we
wanna
can,
do?
but we don't want to go past -2 or past 2.
Because we have no idea
because
what's
we don't know
happening.
what's happening.
This kind of has a parabolic shape, but not really, because
Right, 'cause
especially because of this issue right here.
Right.
So sometimes what happens is you'll graph these and you'll get something that you should be very familiar with, like a parabola, circle, line. Sometimes you don't, and that's okay.
Yeah, sometimes you get really wacky stuff, and that's all right too.
Yeah.
So you can connect these if you want, but don't go past t equals 2 or past t equals -2. That's a no-no.
Right.
Okay.
Eliminating the parameter. So that is where we have a set of parametric equations and we want to get rid of the t's and just have one equation, x and y. So like the last case we did, we maybe could have eliminated the parameter, but it probably would have been kind of a weird graph. So we're going to look at some where the thing you end up with is probably going to be like a parabola or a square root or
a line or
like
something.
something that you should be familiar with.
Yeah.
And the steps are super easy.
And when we say super easy. And
Super
basically,
duper easy.
we're going to follow our rules of algebra for all of this. Like if something equals something, we're substituting it in.
Yeah, and adding things to both
Right,
sides,
right.
dividing things on
Yeah.
both sides.
This is Algebra 1 101 right here.
Right, we're just adding
Big
a
time.
pre-calculus twist.
That's
so,
right.
Step 1, solve one equation, preferably the x equation for t. And the reason we want to do it with the x equation is because typically we like having things solved for y.
Where
and
y
that
equals
will-
people.
Yeah, so if we solve the x equation for t, we plug that into the y equation, will already be solved for y. Watch how this happens.
Okay.
Let's do this.
I am.
All right, we're going to solve the x equation. So I need to subtract 2
Good talk.
because I'm solving it for t.
Yep. That's an excellent plan right
X
there.
minus 2 equals -3t. And then I need to divide both sides by -3. Now we can split this up or we can leave it alone.
Are we going to put this on our calculator in a minute? Because if we are, I'd say just leave it alone.
We can, but we don't have to.
Okay, all right.
Okay. So this is what I get for t, and then I'm going to take that and I'm going to put it right here where this t is in y. So y equals
You just lassoed
5
that thing.
plus well, actually minus. The way and let me make sure that we're all on the same page. I took that negative that's from the bottom and I stuck it in front
Right.
of the fraction.
Right.
It's not in front of x.
It's
The
not in
whole
front of x.
thing-
That's a different thing if it's in front of x.
So 5 minus
The entire deal.
x minus 2 over 3. And I'm okay with that. Are you okay
I
with
mean,
that?
I'm pretty okay with
we
that.
could get common denominators, but
That's a line.
that is a line. How do I know it's a line? Because I just have x to the first power.
Yeah, and it's in the numerator. So x to the first power
Yeah,
in the numerator.
So this is a line, and it asks us.
And you can graph that on your calculator. When you go to graph stuff on your calculator, it says y equals boom.
Yeah, so you can plug that in just the way it is, and it does ask us to identify the graph. That doesn't mean you have to graph it. If you can do it without graphing, then that's great. That is a line.
Dunskies.
Let's do some more of those because some of they can have like some little intricacies is the word I'm trying to say.
Wow, good thing you don't teach English.
Well, okay, yeah. I couldn't agree more.
Okay, me too.
I'm happy where I'm at.
Yeah, ditto squared.
Okay, so right here, if we want to solve this for x, we would square root both sides.
Right.
And when we square root in an equation,
you get plus or minus.
You get plus or minus. Now, let's talk about this. That's why this is an intricacy that we're talking about. Like, do we really want to put ourselves through that? Or is this a situation where it would be better just to go the other way?
I'm saying let's go the other way and solve for y.
And here's the reason why. Because if we're going to have this happen, then at some point we're going to have to restrict ourselves to x being positive. Right? Because
we want to look at that at the end, not at the beginning.
Yeah, because I can't take the square root of a negative number. So so we're going to start over and we're going to say, because of that whole square rooting both sides, let's solve this equation instead. So subtract 1 from each side. Well, that was easy.
Oh.
Y minus 1 equals
It's like
t.
that button you can push in the principal's office, that easy button.
Yeah.
Mr. Kofut has. Do you ever walk in?
I didn't know that, like the Staples commercial?
Yeah.
Okay, so we plug in y minus 1 where t is in this equation. And then we could like FOIL it out, but not necessary. If we wanted to put this in the calculator, we would be kind of stuck. We would have to be like, square root both sides and get a plus or minus.
But when you square one of the variables, what shape do you get?
In general, if a variable is squared, you get a parabola.
So this is going to be a parabola.
It is, and
not a function parabola though.
No, because it's on the wrong side
sideways.
Here. What actually happens is this is going to be it's going to face right.
Yes.
Because y squared means it opens right or left, and then what is it? Is it down 1? Is that where our vertex is?
I believe so.
Down 1.
I think it is.
And we haven't talked about that yet. Like when we say identify the graph, there's a y squared, so that means this is a parabola. But in case you were curious what it looked like, it will look kind of like that shape-ish.
Actually, when y equals 0, x would be 1.
Well, that could happen. No. Maybe. Right here?
Yeah.
Yeah, so, but is that the vertex?
I believe so, yes.
Oh, so that's what I was going to go with.
All right, eliminating parameter A again.
Again. Example 4. Eliminate the parameter and identify the graph of the parametric curve. So let's look at this. Solve x for t. Solve the x equation for t. So square both sides.
Yeah. I'm cool with that.
Okay. So x squared equals t.
I feel like we're going to have a restriction somehow, though.
We are. One moment. So we plug that in over here, and we get 4x squared. But the restriction we're talking about is what values of t. Well, no, actually, that's not the restriction. Whatever we plug in for t,
you're going to get
a positive number because this is a positive square root. So think about it. If you plug in a -2, well, that's not real.
Yeah.
If you plug in 0, you get 0.
Right, which is
okay. If you plug in
okay.
any positive number you want to, you get a positive number.
Right.
So what happens is here, x is going to end up being greater than or equal to 0.
Yeah, there you go.
Although in some ways it may not look like it matters because you square and then it ends up being positive anyway, right? But what that means is when we graph it,
only half a parabola on this case.
It's only half a parabola.
Right.
Yeah. Only the positive x's.
Yeah.
So this is half a
parabola. And this is one of the more subtle details of a parametric equation. Like we look at that and we go, oh, we got 4x squared, that's a parabola, but we're actually only dealing with half of it because of the square root that we had to do.
Absolutely.
Yeah.
Example 5.
Hey, look, trig stuff.
Let's get tricky with it. Okay, so to eliminate the parameter on this one, it's a little bit trickier.
It's trickier.
It's trickier. This may go on for a while, okay? Because we're going to end up using these identities down here.
Triggies.
Yeah, the trig identities. So what matters here is we have sine and cosine, and we know that cosine squared plus sine squared is 1.
Yeah, always. And so we want to try and get that combination. If we see 1, we probably will want to insert sine, cosine, sine squared, cosine squared. If we have a sine or cosine, we want to try and get sine squared plus cosine squared.
Okay, so I'm going to take the x equation, and this is very different from what we've done up to now.
Yeah, this is going to be a little bit on the unique side of life.
Yeah, so we're going to take the x equation, and we're going to square both sides.
It's trigonomics. Now, this is totally legal because what Mrs. Stevenson did on the left, she did on the right. So we haven't violated any algebraic rules.
That's right. And if I actually figure out what that is, it's x squared. Make sure you remember your rules here on the right. This is going to be 2 squared sine squared, which is 4
sine squared.
And that's important.
Yes.
And then we've got...
let's go ahead and do the y side.
Yeah, we've got y squared equals 2 cosine
2 cos.
And so same similar thing happens here, and we get 4 cosine squared.
Now, this is where we're going to take a little bit of a leap of faith, because what we're going to say is that if this is what we've been given, then there's this really cool thing that happens. And if I go, hey, Mrs. Stevenson, I'm going to add x squared and y squared.
Well, and we recently did systems of equations. Let's say, let's pretend like we're trying to eliminate. What do we do when we eliminate? We add the equations together.
Okay.
So we're going to add our equations together.
Got to add both sides, because if you don't, then life could get nasty.
So on the left side, we'd have x squared plus y squared. That equals 4 sine squared t plus 4 cosine squared t. That may not seem super helpful at first for us to do this, but watch what happens. You want to solve?
Okay. Factor out 4.
Okay, factor out the 4. Factoring out the 4.
Remember, anytime we can get sine squared plus cosine squared, we have 1. And anytime we have 1, we have sine squared plus cosine squared.
They are interchangeable.
And looky
Look
here.
what happened. Sine squared plus cosine squared is 1.
That goes away and becomes 4 times 1, which is...
just 4. So x squared plus y squared equals 4. I really hope that at this point in our career this year, we know that this is a circle, especially after the last chapter we did, the systems chapter.
Was there a circle?
We graphed all kinds of circles.
Shut the door. Did we really?
Yeah, we did, all the time.
Okay. I trust you.
Thank you.
Yeah.
I appreciate that.
Yeah, you're welcome.
Example 6.
More trig.
More trig. So
we're going to get triggy again.
And this time we have secant and tangent, but don't worry, there's an identity for that down here. So it actually, though, would probably be helpful for us to change this maybe to, if I got...
think about some different ways that you could rewrite this identity.
We could do
because there might be some different things that come up here.
Yeah, we could do 1 equals secant squared x minus tangent squared x. We could subtract tangent squared x over. That might be more helpful. I feel like that's...
So in this case, anytime we see 1, we have secant squared minus tan squared.
Right.
Similar to the problem we just did.
Absolutely.
Yeah.
So now... what we want to do is we want to solve this equation for secant theta. And hey, this is the first time that we've had a parameter that wasn't t.
Right.
And that's okay. We can have a parameter that's not t.
It's the same in both, so we're good.
Yeah. So
if it said secant theta tangent alpha,
that would be bad.
That'd
be
bueno.
terrible.
Yeah.
And if you were to put this in your calculator, you would still put t in instead of theta.
Correctamundo.
But let's solve this for secant theta, and we're going to solve this one for tangent theta. So I need to subtract 2.
Yes, I like that plan. And divide by 4.
Yes. I thought I'd do it like a step at a time.
Oh, that's fine too.
1 step at a time. Okay, so I get x minus 2 over 4 equals secant. Well, what I want to have is secant squared.
Right.
So let's square both sides of our equation.
Please don't FOIL out everything on the left. Just leave it alone.
No.
There's no need to go crazy here. We're just going to...
Yeah, so on the top, that is x minus 2.
And it's good. X minus 2 squared. Now, please, 4 squared. Now we can do that. That's 16. Come on, boys and girls. All right.
And then secant theta squared is secant squared theta.
Yep, I like it.
Now let's use y. Ooh, the sky. I almost picked the sky color.
The sky color. So y minus 3 equals 5 tan theta.
Right, and if you can leap to the next step, that's
like
fine.
A quantum leap?
I don't think that's a quantum leap. It's a small leap.
Okay.
So then we square both sides as we did with x, because we want tangent to be squared.
Again, there's no need to FOIL out y minus 3. Leave it alone. But please square the 5, because that's one that we can all do.
Yeah. And now what we're going to do is...
secant squared minus tangent squared.
So this time, instead of adding the equations together, we want to subtract them.
Yeah.
Okay.
Yeah.
And this is kind of a loose representation. Like we're going to take this equation minus this one. So left side minus left side
Right.
equals right side minus right side.
Right.
Now I'm going to put that up here. So
It's a good plan.
x minus 2 squared over 16 minus
Yes.
y minus 3 squared over 25 equals secant squared. Now we're subtracting our right sides, which
Hey, that's a one
that
ski.
is 1 because of our identity down here.
Right. So that goes away. That becomes 1. And now we haven't talked a whole lot about this, but I believe this is an ellipse.
This is a parabola. No,
Not a
hyperbola.
parabola.
Hyperbola. It's a
Oh,
minus
it's not
sign.
a plus. Sorry. Yes, that is correct. It's a hyperbola because it's not. It's a minus sign.
Yeah.
Which we're going to actually come to in our next unit, I believe.
Right. So this is in fact a hyperbola that, because of our x's and y's both being squared minus sign in between, that is a hyperbola.
Right. There you go.
There you go.
Yeah, we just got triggy.
With it. Okay, so we are going to write a parametric equation ourselves. We're given an equation with y and x.
Right.
We're going to write our own set of parametric equations. It's going to be great.
And
This can be tricky.
yeah, so it takes practice. Like you have to kind of try and mess up and go, oh, why does this not work? And so some of this you're going to have to actually puzzle through on your own because really you're all going to have maybe a unique question as to how to complete this.
Right. So I think, hey, how about if I make this right here be t?
Okay, that's a good plan.
So that means that I would have 5t squared minus 3 for my y equation.
Right.
Well, if I let t equal x plus 1 and I solve it for x, that gives me t minus 1.
Hey, looky there.
Now let's check it and make sure it works. So y equals 5. Well, we'd solve this first, so t equals x plus 1.
Right.
That's what we're plugging in here. Oh, look.
Hey,
that worked.
hey, wow. That's
Okay,
that's
so that is a
amazeballs
set.
there.
And if you wanted to go the easy way, technically, on any of these, you can make what? What did you say? You can
Just
make
let x equal t.
x equal t, and then y equals your actual
The actual equation with a t in there. And
I mean, I called it the lame cop-out way.
And I was offended that she called my mathematics lame cop
But
out.
technically that is true. If you're stuck and you can't figure out anything else, that's a way to go.
Yeah, so you've got you've got the opportunity.
You can be as creative as you want with these.
Pretty creative actually, because these aren't the only two ways to get that problem.
Right. There's probably
Infinite number.
maybe.
Yeah.
Yeah, probably. So
You know who can count to infinity? Chuck Norris.
Santa Claus.
No. Chuck Norris.
Santa Claus.
Santa Claus isn't real.
What?
Okay, with this section, we're going to transform a parametric equation, which is
Like what we did with regular equations where we did like vertical stretches and shifting and reflecting. Now we're going to say, okay, how does that work with parametric equations? And I think it's actually relatively simple. In some ways, simpler than with normal ones.
because you just do whatever's at the end of the thing.
Yes. So anything that is affecting your graph horizontally is going to affect your your x equation. Okay, you get the next one. So vertical things, anything affecting vertically affects
Y
the y equation. And think about it like horizontal is x, vertical is y. And so let's try this out. And then reflection, just like before, affects the opposite of what you think it would.
Right.
If you reflect across the x-axis, well, that is affecting you vertically.
Right,
so
that's a y issue.
And so if you reflect across the y-axis,
That's an x issue because of the relationship with everything. It should make sense though. I mean, if you slow the brain down and think, it should make sense.
Yeah. Okay. So let's try this. For each of these points, we're gonna write a new set of parametric equations with the transformations they're describing. And here are our original two equations. So we've got x equals t squared plus 2, y equals 4t minus 1. It should be a parabola. You can put that in your calculator.
I mean, it looks like it's going to be a parabola.
So if I'm going to shift down 3, then that's not going to affect my x equation at all.
No, x doesn't change at all because, hey, guess what? That's not left or right. So,
but on my y equation, what that's going to do is it's going to make me move all my y values down 3. So instead of 4t minus 1, I'm 3 lower than that,
right.
Which means
-1 minus 3, which is -4.
Right. So that would be 4t minus 4.
Right.
And you can throw that into your graph like with the original, like put this in as x1, y1, and put these in as x2, y2, and check and see if it really works out. Okay? Right? So.
Did you want me to do that, or were you just telling me?
No, I was just saying we could.
Oh, okay.
We could do that.
I was distracted.
Yeah. And if you don't know how to put them in the calculator, actually after this we'll put.
You know what? A good app to have on your calculator is the it's the Desmos app on your phone. It's a freebie.
Yeah.
You know what? While you're talking about the next one, I'll just make sure. I'll just see if I have that yet.
This is what he just said. This app I know it's on iPhone because he's on an iPhone right now. Or is it?
Maybe it's got to be. Hold on, let me get my iPad.
All right, so vertically shrink by 2. So vertically is going to affect the y equation. And if we're shrinking by 2, that means we're going to
iPad. It's got iPad mini or bigger.
Okay.
Okay.
All of the y values, we're going to divide them by 2. That's what shrinking by a half does. So x again won't change.
Because we're not doing anything left or right.
Right. So you can think of it a couple different ways. Like we could do 1/2. And actually, it only affects the t. Because I was messing with this earlier to make sure I was right. Like, we're vertically shrinking all of our y values, and so we need to do 1/2 times that t. We don't need to mess with the -1.
Because that's where you move up or down from.
Right.
Because if you do the 1/2 times the -1, now that only moves you a half instead of 1. So I get that. Makes sense.
So y equals 2t minus 1, because we're taking our y values and we're shrinking them by a half, but we aren't moving the place where they start, which was -1. Okay, so how about C? Reflect across the x-axis and horizontally stretch by 3.
Okay.
So
if we're going to reflect over the x-axis, then that's really more of a vertical situation than a left-right one. So that means that we're going to have a negative of the t term.
Well, and actually, in this case, it does change the whole thing. Which
It changes the whole thing?
I know that's weird, but if we're going to reflect, it's going to change all of our y equation.
Well,
it
you're
makes
totally
the whole
right.
equation
Yep. It's
negative.
a good thing that you're sitting next to me, because I might have not got that quite correct in my explanation.
And if you were to type this in the calculator, you could type it in exactly like I have it written, or you could distribute the negative.
Either way.
way.
But you think about it, though. If you're at -1 and you reflect, boom, now you're at +1.
Yes. And now horizontally stretching by 3 means we just take the t term and multiply it by 3.
Right.
So that makes it be 3t squared.
Right, +2.
Plus 2.
See, look how much, I almost really honestly feel like this is way easier than some of the other translation. You know, like it's hard to translate an x squared plus 4x plus 1.
Yeah.
That's difficult to move around, but these guys,
you just have to.
You just got to do the right coordinate.
You just have to know that you're affecting the t term only, unless you're reflecting, and then it really makes it pretty easy. So here, let's do a whole bunch of stuff.
Oh my, there's like 3 things there.
We're gonna shift left 5 up to vertically stretched by 3 halves. So
I don't know. I can't even count to 3 halves. Is that like 1, 2?
What's affecting our x equation is
the left 5. Anything left or right.
And that's it. These other 2 are the y. Now, one thing with this left and right business is that when we normally translate, we always have to like do an opposite situation.
Right. It's a super secret opposite society.
But that doesn't apply here. We're taking all of our x values that we have, which right now are t squared plus 2,
and we're moving them all
to the left 5.
Well, here's the other thing with the super secret opposite society. We're talking about things inside of parentheses
right,
also.
And
there's no parentheses here, so that's another way to remember that rule.
Okay. So that would be t squared minus 3.
All right.
These other 2 things are going to affect our y equation.
We've got a combo.
Up 2, but we're also vertically stretching by 3 halves.
Right.
So that'll be...
So the up 2 part goes on its own, because if you multiply the 2 by 3 halves, that is not going to be 2 anymore.
Right.
Yeah.
Right. Yeah.
It'll be
so we do
3.
these separately. The vertical stretch comes here in front of the t.
Right.
The up 2 is going to affect this minus 1.
Right.
So this equation, we do 4 divided by 2 is 2. 2 times 3 is 6. And then -1 plus 2 is plus 1.
Yeah.
And totally give this a try and make sure that you can actually visually see that these things are happening.
Right. Go ahead and write that calculator back up there. You scribbled it out. So if you have an iPad, or if you have a tablet, or if you're on your computer, this website, Desmos.com, or the Desmos app is brilliant for graphing. Pretty simple, stupid.
I love the
graphing.
website.
Like,
so if you're ever at home and you have a computer and you don't have your grapher with you,
that you're
you
comfortable
got
with.
one.
You got one right
Desmos.
there. Yeah, it's excellent. Okay.